Okay, geometry students, welcome back from the weekend. Today we're going to do one small topic, not a big topic. We're also going to do a lot of review from last week's topics, so we're definitely going slower than we normally would go if we were in school. So this is a great chance for you to learn something without as much pressure. Don't forget to email your teachers with questions or post on discussion boards. So before we even start this area of a sector topic, we're going to review four things. So actually 7 things. So let's go through the first 7 questions. So I want you to pause the video, answer the first 7 questions as best you can. If you can't answer one, skip it and go to the next one. But you should be able to answer all of these. They're all from last week. And I'll quickly do each one. So pause the video, do problems 1 to 7 from last week, and then let the video run. Okay, hopefully everybody took advantage of that. What is the name of the circle? We name the circle P because that's the center. They didn't really tell us that C is the P is the center, but if that, in lack of anything else, we're going to make that assumption. What is the circumference of the circle? Well, circumference, if you remember, is equal to 2 pi r. That means 2 times pi times r. So in our case, right, C is going to equal 2 times pi times 5 feet. So 2 times 5 is 10. 10 times pi is just 10 pi. We leave it as 10 pi. We don't multiply the pi through. And we want to say feet. Okay, now what is 10 pi? Well, 10 pi is really about 30, right? Or 33, 31 really, sorry. Because it's times 3.14, right? So it's about 31. Approximately. Okay, and this would be feet. So if this was a real life application, we'd kind of want to round it. So we'd either say 31 feet, or we'd say about 30 feet, or 31.4 feet, depending on how much accuracy we needed. But that's what it would be equal to. But we like to leave it in terms of pi, so there's no decimals to deal with. That's all. So 10 pi really means about 31.4. 10 pi. All right, what is the area of the circle? Well, if you remember the area formula right here, area equals pi r squared. Okay, pi times r times itself, right? Times r again. So what's the area of the circle? Pi times 5 feet squared. So it's 25 pi, and then the feet is also squared, so it's feet squared. So it's 25 pi, and then of course feet squared. Whenever you order area, if you go to order buy a rug, and you go to a store, they're going to say, well, how much square feet do you want? They don't want to know how long the rug is. They don't want you to tell me it's 10 feet of rug because I don't know how wide it is. So you say how many square feet? So 25 pi square feet. Now again, pi is about 3, a little more than 3. So this is a little more than 75, right? So roughly 76, 77, 78, somewhere around there. A little more than 75. AP, 2 capital letters next to each other. What does that mean? That just means the distance along the segment, or the length of the segment, right? So the distance between those 2 points, A and P. Well, that's easy. They told you it was 5 feet, so it's 5 feet. Nothing surprising there. Okay. What is the length of the semicircle? Now, this is arc length, even though they didn't tell us this, right? But they really implied here. So if you want to write it here, and I would, what is the arc length of the semicircle? So the semicircle is from here to here. Okay, and if you remember what arc length is, right? Arc length is some fraction of a whole circle, so we always put a little fraction symbol here, times the circumference, which is 2 pi r. And they didn't give us an r here, so I'm going to give you an r of 5 from above, okay? So this should be 5 feet. You may have this when I fix this on yours. So there'll be 5 feet marked there. So it's going to be L equals some fraction. I know that looks like a weird symbol, but that's just some fraction times 2 pi 5. So I'm going to get rid of this little circle here, right? We don't need that. I'll erase it. Okay, some fraction times the circumference. This is the circumference, see? Be careful because You're making it out more complicated than it is, but this 2 pi r up here from the very top is the same 2 pi r here. So this is this, right? Is this. So the only new part, right, is this fraction because it's not a full circle. That's all. That's the new part. So if you look over here, right, what is this shaded region over here? How much of a circle is this, right? Oh, it's half a circle. Half a circle. Now that's not the way you were taught with the formula, right? But that's the result of the formula simplifying. But if you can look at the circle and realize, oh, that's a half circle, so it's half, that's all you really need. Now the longer way to do it is what you were taught, is theta, right, over 360 degrees. And how many degrees is this half circle? Well, it's 180 degrees, right? 180 degrees. That's what theta is. That's the central angle that's intercepting this purple arc, that's creating this purple arc. So I'm going to erase the theta here from the formula, and I'm going to put in 180. But as you all know, right, what is 180 divided by 360? What is 180 divided by 360? Well, it reduces to 1 over 2. No big surprise because that's half a circle. All right, so the length of the semicircle is 1/2 times 2 times pi times 5. And this is feet, 5 feet. So 1/2 times 2 is 1, right? 1/2 times 2 is 1 times pi times 5. 5 pi feet, or about 15 feet, a little more than 15 feet. Why do I say a little bit more than 15 feet? Because pi is roughly 3. It's a little more than 3, of course, right? But pi is roughly 3, so roughly 15 feet, a little bit more than that. All right, what do we call segment AB? A segment that goes from one end of the circle to the other end of the circle, right? You knew this before you ever took this course. That's called the diameter. So let's put in the word diameter. Okay, a diameter is a chord. A chord is a segment that goes from 2 points on a circle and connects them. That's called a chord, which may or may not be new to you, okay? So this is called a chord because it goes from A to B. A chord connects 2 points on a circle. This is a chord over here too. I'm going to erase this one in a second because it's not really given to us. That's a chord also. Okay, so that's new. A diameter is a chord. It's just a special chord. It's a special chord, but it is a chord. All the same. AB, when I see 2 capital letters next to each other, that means the distance from point A to B. How far is it from A to B, or what is the length of the diameter? Well, if it's 5 halfway to the radius, then it's 10. And of course, 10 feet. Okay, so let's do the new stuff. Let's do the new stuff. So now, just like I wanted to know what half of a circle's arc is, right? Now they're asking me, and this is our new topic, the area of a sector, okay? So a sector is a section of a circle. This gray section of a circle, this gray section of a circle is a sector, right? So a sector is determined by, just like the arc, it's determined by the central angle. This is a 180-degree central angle. So you have a sector of a circle, like a section, right? The word section is kind of like sector, section, right? It's kind of like sector. If you ever watch any silly army movies or sci-fi movies, they're in Sector 7, the aliens in Sector 7, right? Sector, we call it. It's a section of a ship or a section of a map, right? So we call it a sector. Okay, so what is the area of this sector? That's what they're asking us. How much area is this? Well, it's pretty obvious. I don't have to really even teach you this. How much area is the full circle? We did it way back up here. Let's take a look with our green highlighter. The area of a full circle is 25 feet. Same circle, right? Same radius, of course. So what is the area of a half circle going to be? 12.5, right? Or 25 over 2, right? Of course. So where do you know the answer? It's 12.5 pi. I know you said I don't like decimals, so we're not going to do decimals, but I just wanted to show you that it's half of 25, okay? We're going to write 25 pi over 2 because unless somebody tells me it's okay to use decimals, we're not going to. And 25 pi over 2 is the same. That's 12.5 pi. And of course, this is feet squared. All areas have to have units like this. Okay, now, what did I do to get that? Was there a formula? Not really, right? Not really. It's basically just this. It's the fraction of a circle, and we had a half circle, right? That's the same fraction you use when you do arc length. And then the area of a circle. We know what the area of a circle is. It's pi r squared. That's the area of a circle, right? So it's the full circle times some fraction. And we're going to talk about this fraction in a second, although you already know it because you've used it when you did arc length. All right, no big surprise. Let's take a look at the next problem here. What is the area of that shaded region? Well, there's a 90-degree angle here, right? So that means there's a right angle here. So that's what? What fraction of a circle is this? That's a quarter of a circle, right? Or if we wanted to be fancy, and that's not wrong, but I could say, well, the central angle is 90 degrees. I can't really fit it in there, but there it is, 90 degrees. Oh, the central angle is 90 degrees, and there's a total angle measure in a circle of 360. Oh, that's 90 over 360 times the area of a circle, right? So it's 1/4 times what? Get the highlighter. Times the area of a circle. See, times the area of a circle. Same thing. No big surprise. So all we're doing is we're taking what we know is the area of a circle. Oh, pi r squared, but I know what r is. Sorry, let's say 5 there. So pi times 5 squared. Right? So it's 25 pi times a quarter. 25 pi times a quarter is like divided by 4. And that makes sense because it's half of this one up here from figure 2. So figure 3, this really goes here, sorry about that. So figure 3 answer is really just half of figure 2's answer. So if I multiply figure 2's by a half, I stick a 1/2 here, I get this over 4. I'm not going to leave that there because that's not the answer. Okay? So the entire new thing that we're doing, right? The entire thing, the entire lesson comes down to one fraction. And it's a fraction you've already used because you used it when you did arc length. Basically, you knew this green part, you knew the area of a circle, this shaded green, you knew the area of a circle, that's from middle school. And all we're doing is adding a fraction to it. And where do I get this fraction? I take the central angle, which is 90 degrees, and I divide it by 360. Because that tells me what fraction of a circle. This is a quarter circle. This is a half circle. This is a whole circle. Now, this is a little bit of thinking. It says, what's the remaining area? Well, if the entire area is 25 pi, and the gray area here, in green I'm going to put, right, in green here, is 25 pi over 4. Sorry about that. Right? A quarter of a circle, what's left? Well, what's left is 3/4 of a circle, right? 3/4 of a circle. Now, how did I get that, right? Well, we have to convert, we're adding two fractions here we need a common denominator, so I've got to change this to be 4. And therefore, if I multiply the bottom by 4, because there used to be 1 here, I've got to multiply this by 4. So that's 100, right? And just to make sure, let's make sure 100 divided by 4 is what? 25. Okay, so it's equal. So now I'm back to what I had before. So I just made a common denominator here. Okay, and then I subtracted this one. So it's 100 minus 25 pi is 70. 100 pi minus 25 pi, 75 pi over 4. It's basically what's left, right? It's basically what's left. Okay. Of course, you could just take the gray, which would be one of these, and there'd be 2 more, and just multiply it by 3, right? So you could just multiply this green answer by 3. That would do it too. So no big surprise. Okay, so just to sum up again, right? It's the same formula that you used for arc length, except we're doing area, not arc length, right? Area of a circle. Okay, so the area of a sector, like the blue sector below, okay? This is a sector, right? The area of a sector is equal to some fraction of a circle. So depending on what the angle is, it could be a fourth of a circle, a third of a circle, an eighth of a circle, a tenth of a circle, half of a circle like we had, and then multiplied times the area of a circle. So this is not new. This is the only new thing right here. Okay, so armed with that formula, this should be really, really easy. I want you to pause the video, go to the third page here in the slide, in your notes, pause the video and try this problem, and then I'll do it with you. Go. Okay, what is the name of the circle? Well, that's easy. It's circle O. What is the measure? The measure, usually we write this, by the way, as this. We don't really say the word measure, right? So usually we write measure of arc AB, of arc. This is arc AB. So arc AB goes from here to here. What is the measure of that arc? Well, it's equal to the measure of the central angle. That's the central angle that intercepts this arc. So they're both the same. Okay? So the measure of the arc is 120 degrees. Now, what is the length of arc AB? Well, that's a whole different story. Now you want to know how long it is from here to here. Not the measure of the arc, which just tells us the fraction of a circle, but how long it is. Well, I can tell you right away, without any big work here, how long it is all the way around the circle. Hopefully you know the name of that. All the way around the circle is called circumference, and the formula for circumference is 2 pi r. All the way around the circle is 12 pi, right? So the circumference of the whole circle is 12 pi, right? 2 times pi times 6. 2 times pi times 6 is 12 pi. And they didn't give us any units here. Usually we would use units, but very rare problem they don't give us units, so I'm just going to say 12 pi units. Okay, my pie looks terrible, so I'm going to fix that pie. Not happy about it. I'm not a great cook, so I can't make good pie. Okay, 12 pi units, all right? Now, that's not the length of AB, though. That's the length of what? Of the whole circle. So we have to get rid of a bunch. We don't want all of this, right? We only want all of that. We only want what? We only want 120 degrees. Now, how many degrees in a full circle, right? How many degrees in a full circle? Well, there's 360 degrees in a full circle. I mean, you can kind of eyeball this and see it's pretty easy, right? You can kind of see, like, if I drew another kind of line here, this would be another third, and this, well, this is sectors I'm doing, but if I go back to arcs, right? Sorry, but if I cut in thirds, that would be 1/3, 1/3, or 2/3 together, but 1/3, 1/3, and 1/3, of course, or 1/3 plus 1/3 is 2/3, so what's left is 1/3. So this is a third of a circle. Of course, if you use the formula, this is what you're going to get, but you have to reduce your fraction, right? 120 goes in 3 times. Okay? And then times what? Well, we already did the work. It's right here. We just steal it here, right? Times, but I'll do it the long way. Times 2 times pi times 6, which is 12 pi. Okay? So in the numerator, I'm going to get 1 times 2 times pi times 6. So that's 12 pi. The denominator is 3. And of course, there's no denominators here. But we would just put 1s there, right? So it's times 3. And this is units. It's a length. It's not units squared, it's units. And then, of course, 12 over 3 reduces to 4. So that's how long it is. It's about 12 units. If units were meters, this would be 12 meters. It's not 12, right? Pi is 3.14, but it's about 12, 12 and a half, right? A little more than 12, okay? What is the area of the shaded region? Okay, the area of the shaded region. That is not this, right? That is not this. That is this. So it's not a third of a circle like we did before. It's what? What fraction of a circle is this shaded region? Well, if this is a third of a circle, what would this be? 2/3 of a circle. Very good. 2/3 of a circle, okay? So the area of a sector, if we go to the other page, remember, it's the fraction of a circle it is, right? Which I can use this formula if you want to. And I will, even though you don't really need to. So the area of the circle is, well, what's 120 from 360, right? A full circle is 360. What's 360 minus 120? 240, good. Over 360. See, that's using the formula. Did I really need a formula here? No. Because this is the same as 2/3. It's 2/3, right? It's 2/3, see? 2/3. Well, that's not because those are 2 and 3, but it is 2/3. Just when you reduce it is what I'm trying to say. Okay, times pi. Times pi r. R is 6 squared, and it's units, right? Okay, so the area of the circle, the area of a sector is the area of a circle, that's what I just circled there, times the fraction of a whole circle that your sector is. So we have 2/3 of a circle, times the regular area, which is 36 pi. So it's 36 pi times 2/3. So I didn't mean to write that. I mean, you could, but I wanted to skip that step. So it's 2, this 2 here, times 36. So that's 72. Over 3 times 1, y1, because this is over 1, over 3. So it's 36 times 2 is 72 over 3. And let's see, does 3 go into 72? It does, 24 times, right? So the final answer is 24 pi. Units squared. We don't have any units here, so we're going to write units squared. Okay? Just to go over it again, right? The area of a sector is equal to this case, 2/3, okay, times pi times 6 squared, right? And that's equal to 2 times pi times 36 over 3. That's how this all works out. Of course, you can reduce the 36 into 3 first, but that's a little dangerous. Sometimes you guys forget when and when not to do that. In this case, you could. 72 pi over 3, 24 pi. What is the remaining area? Well, if that was 2/3, we only want to take 1/3 for the remaining area. If that was 2/3, we only want to take 1/3 of pi r squared. Okay, or 1/3 of 36 pi. And 3 goes into 36, 12 times, so it's 12 pi. Makes sense. So the whole thing is 36 pi. By the way, I never filled this in, so let's just do this, right? So this is 4 pi units. And AB we didn't do. Oh, this is supposed to be, yeah, this is not supposed to be done here because we can't figure out what AB is, so just ignore this problem. Okay, and then this one, of course, we just finished earlier was 12 pi units. Okay, now that's all there is. That's the entire thing, is just what fraction of a circle do you have, which you've done before. You did it last week, and multiply it times pi r squared. Just that formula right there. Very, very simple. Area of a sector. Now, when you know that, you can do some really hard problems. So let's take a look at this really hard problem. So I want to know, what is the area of this red region here? That's a really hard problem. So the key here, well, if you want to pause the video and try these three, they're very difficult problems without any help, so you're welcome to try it. If you were thinking about going to honors next year, this would be the kind of problems we would expect you to be able to do right about now. So if you want to pause the video and try them to see if you really could handle honors, you can welcome to try it. Okay, so I want the area of that red shaded region. It's a weird shape. There's actually a name for this. It's actually called a segment, but we don't use that terminology because it gets too, although it's correct, it just gets too confusing with segments, like a line segment. So we're just going to call this the shaded region here. Okay, we want to know what it is. We can't really figure it out. It's a weird shape. It's kind of like a pizza crust almost. So, but what we could do, what we just learned about, was the area of a sector. So rather than doing the red area, I'm going to do this whole area. I'm going to do the green area and the red area together. Why would I do that? Because that's a sector. Okay, the angle is 90, right? So it's a quarter circle. So I know that the area of the circle, the area of the sector, excuse me, the area of the sector, that's 1/4, it's a quarter circle. is 1/4 times pi r squared. Okay, there's no units here, so we'll use units. Right? So what I just found is the area of the black. Watch. The black is the red and the green together. I'm going to erase that in 2 seconds because it's going to overload the problem with too many lines. But I just found the area of this entire black region, right? The whole quarter of a circle. The whole thing. The red and the green together. So the red and the green together is 1/4 times pi times 1 squared. That's pi over 4. Okay. Now the area of the green, you should know, the green is a right triangle. The area of a right triangle is always really easy, right? The area of a right triangle. The area of a right triangle is 1/2 the base times the height. But in a right triangle, the base and height are the legs. And we have 2 legs here. So it's 1 times 1. 1/2 base times height is 1/2. So the question is, right? And I should have made this green, actually, but it's okay. So the black meaning everything that we had before, the green meaning just this green. How would you find the red? Well, you would take the black region that we did earlier, and you would subtract, because the black region was all of this, right? So I would subtract from that the green, which we just found, the area of a circle, area of a triangle, excuse me, right here, and subtract the 2. And that's the answer. Now, you got to get a common denominator, so I'm going to change 1/2 to be 2/4. Okay, and I get pi minus 2, because you can't combine those, they're not like terms, over 4. Now, what is that in real life? Well, it's about a quarter. It's about a quarter, right? Because pi is about 3. It's a little more than 3, I know, but roughly 3. 3 minus 2 is 1. So it'd be 1 over 4 is 1/4. So it's a little more than 1/4. It's probably like 0.29 or 0.28, a little more than 0.25. Okay, in this problem, what is the area of the gray shaded region? Again, we face the same problem where I can't find this weird area, but I could find the area of the entire picture of the square, right? So the area of the square, which is everything, right? Which equals the area total. The entire thing is what? 8 times 8, right? So it's 64 feet squared. Because that's the area of a square, right? Length times width, 64 feet squared. Now the area of the circle we just learned about. Well, not just learned about, you knew that. And the problem is you don't know what the radius is, but you do know what the radius is, because if that is half of all the way across, and the 8 goes all the way across, then I know that this is 4 feet. So the area of a circle is pi r squared, which is 16 pi feet squared. Okay, but that's not the answer to the question, right? The answer is, what is this shaded region? So I'm going to take the total region minus the circle. So if I cut a circle out of a square, those 4 corners would be what was left. So the final answer is the area equals 64 feet squared. Well, we can put the units at the end, so we can say 64 minus 16 pi. Now 16 pi is roughly 48. It's probably around 50, 51 because it's 16 times 3, right? Roughly 48. It's definitely more than 48. But we're going to leave it in pi form. We're not going to use decimals unless they tell us to. Okay, the last one's not too hard. You should be able to figure this out. So it's basically what? This part of a circle. Okay. What is your entire figure? So it's that part of a circle. What is that? Well, that's 3/4 of a circle, right? And the area of the circle would be pi r. R is 2 squared, 2 feet squared, right? Okay. But it's not a full circle. And then plus what? Plus this region down here, which I'll do in purple. And that's just a square. So plus base times height. So plus 2 times 2, which is 4. And that's the whole thing. So let's simplify it. So this would be 4. So it's 3 times pi times 4 divided by 4. Well, if you're going to times by 4 and divide by 4, guess what? That's what you get. Let me put that in green, actually, just so it's a little clearer that I'm doing the green work here. Okay, so this ends up being 4 pi, I'm sorry, 3 pi, excuse me. 3 pi, because this is 4, and 4 times 3/4 is 3. Okay, plus 4. And believe it or not, that's the answer, because you can't mix the pi term and the non-pi term. And so we would say feet squared. And I really should have said area equals here, but I didn't. Now I did. Okay, what is 3 pi times 4? It's roughly 16, 17, right? Because 3 times, I'm sorry, 13, excuse me, 13 or 14, 13 or 14, excuse me, 13 or 14, because this is really about 9. 3 times 3 is about 9, a little more than 9. Plus 4 is 13, so it's a little more than 13. So maybe it's 13.5 or 14 or 13.3. We don't really know, right? But they didn't ask us for it in decimal form, so that's the answer. I always leave things in non-decimal forms unless they tell me. The only thing I want to make sure I do is I want to make sure I put a parentheses around it so that I get the feet squared, so that the feet squared applies to the whole thing. That's just a single number. We just don't know what it is, although we have a good ballpark idea. Okay, check online for homework, and we'll go over to homework tomorrow.